Hey everyone, welcome back. This is Professor Xiao. The purpose of this video is to help you with a specific homework question. The question is hands-on practice, so let's go to a Jupyter notebook. All the demos in this video is based on the dataset Yelp1. This video may use some of these packages, especially RE for regular expression, GenSim, and sklearn. Note that I use the NumPy random seed 1 and random state 1. After reading the dataset, here is a high-level information about the dataset and the columns included. I printed the first 10 rows of the data by selecting a few columns. We will be focusing on the review text column of this dataset, which includes each of the review texts. The first review text, the second review text, and such and such. Each review text is referred to as a document. This is how NLP programmers refer to the texts, and the entire column of review text will be called a corpus. Now let's look at a specific problem. The demo in this video assumes that you have followed 2 other videos on how to clean and prepare or pre-process the Yelp review text corpus. So for the demo, I will use the review text column in the data frame df2. The purpose of this video is to demonstrate how to quickly train and fit an LDA, latent Dirichlet allocation model to the Yelp review text data, and after training the model, I will briefly explain how to understand the result output of the model. This demonstration assumes that you have watched several of my other demonstration videos on how to clean, pre-process, and prepare Yelp review text data, how to train a bag of words model and get a term frequency table, as shown here. The Z here is the term frequency table as the results output of the bag of words model vectorizer. So here I'm going to quickly train an LDA model. A few arguments to pay attention to. For this model, I will specify 5 topics. Number of components is 5, so that I have predetermined that 5 may be an appropriate number as the number of topics for this dataset. Later, I will discuss the alternatives. Random state is the random state number on top of the Jupyter notebook that I specified. And the learning rate, which is the optimizer, is set as the batch. This means that the model will apply optimization on each of the batches. After defining the model object, you will need to fit and transform the data. Now, the data that feeds into the LDA model is not the raw text data, but the term frequency table, or the feature vectors matrix, Z. And recall that when you train the bag of words model, you need to specify the MaxDF, the maximum document frequency of the terms to be preserved in the feature list. This setting could directly affect the results of LDA. So when you try to modify the LDA model to improve the results, this is the step that's part of the changes that you will need to make. Consider using alternative values for the MaxDF argument for the bag of words model, by which you get the term frequency matrix, and later also change some other relevant arguments for the model in order to improve the results. Let's get back to the LDA model. So I will run this cell. Note that LDA model requires a longer time to train. So I set up a time tracker here to report the number of seconds that's used to train this model. Now let me run it. Now training has completed. It used almost 1.5 minutes to finish the training. The dataset is quite large, so this is quite reasonable. Let me talk a little about the result of this. So LDA is the model object. It's fitted to the dataset, transform the dataset into a result outcome. The model itself contains several attributes that include the results. I will extract them in another video. I will extract something called topic word distribution table or topic word importance matrix, among other results. And the RES LDA, RES refers to results. RES LDA is another component of the result. This matrix or table is a document topic probability distribution table. It has as many rows as the dataset has, so this result should have 15,000 rows. Each of the column represents a topic, so there should be 5 columns of this dataset. Let's check. There you go, according to the expectation. So what is each element here? First of all, for a specific topic, each of the 5 columns represents the likelihood or probability that a document is possibly about that particular topic. So in this sense, for this particular matrix, the numbers represent probability, and if you were to add each of the 5 elements in a particular row, it should add up to close to 1, which is 100% likelihood. This concludes a demo about training LDA and how to understand the results output. I hope you enjoyed this video. See you next time.